Okay, so here's your video taking you through how to do some of these rational functions where you have a slant asymptote. I'll work through one of them. I'm going to work through number 19, but I'll help you set up the other ones. Okay, so number 17, if we're looking at this one, we have to kind of know what our rules are. So the degree of the top is 0, degree of the bottom is a 2, because this is going to end up foiling out and you're going to have an x squared. Then we look at the bottom, the denominator, to figure out if we have a vertical asymptote. Set that equal to 0, you get x equals -4. That's the vertical asymptote, okay? So you're only going to have a vertical asymptote at -4, and we'll pick points around here for your xy chart. So I'll just kind of give you some information for that. So I would probably do like a -3.5. That's on the one side, so I'll do a -3, -2, -1. And then I got to go to the other side of the -4. I'll do a -4.5. -5, -6, -7. That's the XY chart that I would use for number 17. And if you can't see what's going on when you get close to the asymptote, go even closer. So maybe 3.9, a -3.9, and -4.1. Okay, so number 19, we're going to work through that one completely. So we need to use our new rules here. So you want to multiply this all out. So this will be x squared minus 8x plus 16. With these questions, we have a rule where the top degree is bigger than the bottom degree by 1. Okay, so if we're looking at this over here, your top degree is a 2, the bottom degree is a 1. So you're larger than the bottom by a degree of 1. When that happens, you have to use synthetic division or long division to find the slant asymptote, okay? And when you do that, you're going to use everything except for the remainder. So this actually works where I can do synthetic division here. So I'm going to put a +2 in my box. And then I'll have a 1, a -8, a 16. So 1 drops down, take it times the 2, I get a -6, take that times the 2. Well, this part, it doesn't really even matter. The remainder doesn't matter, okay? So I don't care about that. If I take this and turn it back into an equation, I have x minus 6. That's the equation of a slant asymptote, x minus 6, okay? So if I do y equals x minus 6, I have to graph that first, and then I'm going to graph my other asymptote, which is x equals 2. So I have this asymptote and this asymptote here. Those are the two that I graph before I make my xy chart, okay? So let's graph the x equals 2. That's right here. And then let's graph the x minus 6. So this tells me I start at -6, I have a slope of 1. So -6 is here. My slope of 1 goes about like that. Okay, so there is my slant asymptote. Now when we make our slants and we graph this, we're either going to have something out here like that, or we're going to have something inside between these like this. Okay, most of the time we get this stuff over here where you get something kind of right in between those two asymptotes. All right, so let's do our XY chart for this now, and then we'll fill that in. So the XY chart, we're picking points close to this asymptote. So let's do a 2.1, and then we'll do 3, 4, 5, and then let's do a 1.9, 1, 0, -1. So from there, it's just plug everything in your calculator. All right, so I would plug everything into this one right here. And remember, when I plug it in, the top has to be in parentheses, so I would do parentheses, and then plug in my first number. So let's do 2.1 minus 4 squared divided by, so I would just press the divided by button, and I have to have parentheses on the bottom. 2.1 minus 2, and maybe you want to put the 2.1 in parentheses again on the bottom. Okay, so I'm going to do my 2.1 and 1.9 here quick, and then I'll fill in the rest of it from my XY chart on my calculator. If you have a TI-83 or TI-84, you can use those, but you want to make sure that you fill out your XY chart. All right, so there's my XY chart, so check your work, check your answers with those. Again, it's just using your calculator. Make sure you're using parentheses correctly like that, and then we graph it. So the 2.1, we can really kind of see that that kind of shot up there. So 2.1 and then a 36.1. So I'm 2 here, 2.1 a little past there. And then we'll just say 36.1 is kind of up here somewhere. And then I got a 3, 1, 4, 0, 5.3. So you can kind of get the general shape of that. So remember, I'm not going to cross those asymptotes. I'm going to get close to them. I won't cross them. So that's the parabolic shape at the top there. And let's do the bottom one. So we have a 1.1, or excuse me, 1.9, and we're at negative 44.1. So that's down there somewhere. We got a 1, negative 9. So we're here. A 0, negative 8. So we're there. Negative 1 and negative 8.3. So we're kind of there. So again, you can kind of see my graph makes that shape. Okay? So it's very similar to the ones that we did in class, to the other rational functions. The only thing that's extra is when we have to find that slant asymptote. So we found that slant asymptote that was y equals x minus 6. You got to remember how to graph a line and then go from there. Just plug everything in. Okay? 21 is very similar. I'll set it up and I expect you guys to finish it. Okay? So 21, I can't do synthetic division anymore straight up. I could, if I wanted to an x minus 2, x plus 2, okay, because x squared minus 4 factors to that. And then I would use a 2 in my box and a negative 2 in my box. So you'd have to do synthetic division twice, okay? If you don't want to do that, long division is the way to go. It's actually quicker here. So x cubed plus 1. Remember, you probably want some 0 x's in there, like so. So that way you have your placeholders, and then we're dividing by this right here. Okay, so we look at the front two terms. X cubed divided by x squared gets me to an x, and then I have to multiply that through. I would get x to the third, and then we maybe want a 0x in here also, just for a placeholder. So it'd be plus 0x squared plus a 4x, and then we're subtracting those. So those go away, the x cubes go away, the 0x squareds are 0 anyway, and then I have a 4x. I have to bring down that plus 1, and then try to do it again, which I can't. So I would have this as my remainder, right, because there's an x to the first here, not an x squared. So I got to work with that. So that's just my remainder. I don't care about that. So the slant here is just a y equals x. Okay? So I would have a slant asymptote of y equals x. And then I set the bottom equal to 0. So I needed to factor that to see where I would equal to 0. Or I can solve it like a square root equation. Square root both of those. I'd have x equals plus or minus 2. So I'll have an x equals 2, x equals negative 2. Okay, so now I would have these three asymptotes. I have these three. So I'm going to have to pick a few more points. I'm going to have to pick points in between 2 and negative 2. I'm going to have to pick points to the right of 2, and then pick points to the left of negative 2. So your XY chart might have 8 to 12 points. Okay, last one here I'm going to show you guys is when you have a hole in your graph, or it's called a discontinuous point, all right? So we have a removable discontinuity. So where is your graph undefined? We look at the bottom. We know that we're not going to have anything, x cannot equal 4. Okay, we know that just by looking at the bottom. But we want to figure out what kind of discontinuity that is by seeing if anything factors itself out. So let's redo this one down here, and we factor the top. Two numbers that multiply to an 8 and add to a 2, so that's going to be x minus 4, x plus 2, and then in the denominator we still have the x minus 4, and you see that those will cancel, and I'm just left with an x plus 2. When you have factors cancel out like that, that's called removable discontinuity, okay? So really, you have this to graph, and then this discontinuous point is just a hole in the graph, okay? So we graph x plus 2. I start at 2, I go up 1 over 1, and it looks like this. So I'll have this line, That's x plus 2. I have a hole at 4. So I find 4, find my graph, and there's a hole in the graph right at 4. So it's just like a line with a hole in it. And that is how you graph those. Okay? So I expect to see these 4 problems on your homework when you turn them in, 17, 19, 21, and 28. Okay? If you have other questions on these, let me know. Thank you for watching the video.